morning. Welcome to the session on exploring collectors. My name is Venkat Subramaniam. I'm going to talk about this one little utility class that's available within the JDK, but I often feel that it's one of the things that's underutilized. We can learn quite a bit from the power that it offers, and that's what I want to spend the time on, talking about some of the things we can do with it. So I want to step a little bit back to functional programming, talk a little bit about some of the functions that are available, and then tie it back into collectors and how we can use it. If you do have a question or a comment, I'll be delighted to hear from you. Just draw my attention and speak up. I'll be more than happy to listen to what you have to say. So let's get started. Well, one of the cool things about Java in the past few years has been that when it comes to Java, in the past we did mostly imperative style of programming and object-oriented style of programming. Well, now of course, Java has one more capability added to it, which is in addition to being imperative and object-oriented, we can actually write code in a functional style as well. Now, when it comes to functional style of programming, what are some of the tools we often use when it comes to that kind of line of thinking and line of coding? Well, if you were to really write code in traditional Java, you're probably going to use mostly things like a for loop and a while loop. In fact, I would challenge you to go back to your applications tomorrow and do a grep on the number of times you use for in your code. It's kind of scary, isn't it? Well, in a very similar way, when it comes to functional style of programming, we often use things like filter, map, and reduce. These are the tools of the trade when it comes to functional programming. So what do these really do? Well, the filter, of course, is very useful to, I used to like to use the word cherry pick objects from a collection of objects. So you can say, here are the data that we are receiving, and of this data, I really want to get these select data, and a filter is really useful for that purpose. A map, on the other hand, is really useful for transformation. So it's a transformation of data. So when you get some data, you want to transform the data to something else. For example, we have a collection of people in the room. Maybe all I want is a collection of the first names of the people. Well, that's a transformation or a map operation. While filter and map really go through one line of thinking, I like to think of a swim lane, if you will. So a filter only looks at its own data. Map only looks at its own data. On the other hand, reduce cuts across those chain of data, and it's kind of like crossing across a swim lane, and reduce is an extremely powerful operation in general. So let's spend a minute looking at these things just to get a feel for what it really means. So let's say for a minute that we have a list of numbers, we'll say. In this case, I'm going to say numbers is equal to, let's create a list of values, list of numbers, let's say 1 to 10. And given these numbers, what I really want to do is to only, let's say, select the even numbers in this collection. Well, then what I can do is I can say numbers.stream, where stream is an internal iterator, and then we can do a filter operation on it, and we can say, given an element, give me only the even numbers in the collection, and then of course we can do a for each, and we can simply take the value given to us, and we can print it out. So in this case, we're going to only get the even numbers in this collection, and then have that printed. Well, as we can see in this case, the filter operation was useful just to extract only the even numbers in this collection. However, we can perform a transformation as well. So given, for example, all the even numbers, we can take the even numbers and we can double those values. And in this case, of course, the map operation gave us the ability to take this transformation of the data. But both the filter and the map, if you really notice, are only working with the numbers given to them. And that's what I meant by the swim lane. So you're looking at one value which is being filtered, and that value potentially being mapped. And you're not looking at your neighbors. You're not looking at the left value or the right value. You're just focused on one value. On the other hand, there are times when we want to go laterally across multiple values as well. Here's a way to think about it. Imagine for a minute that I want to total the age of everyone in this room, and we're going to start with him. He's not smiling at this point. No, I'm not going to ask for your real age, but we're going to start with him, and I'm going to give him a 0 as a value. He takes 0 and adds his own age to 0. Well, that's a total of his age with everybody to his right, which is nobody right now. And then he passes his age to the person next to him. He takes the given value, adds his own age to it, and then passes it to the next person. And then if we just go through that throughout the room, well, that's kind of what a reduce operation really is. So a reduce operation is where you take a collection of data, but you process the data one at a time, so to say, reducing it to a single value. So in this case, what you could potentially do is you can say a dot reduce, for example, and the reduce is going to take an initial value that you want to start with. This is actually called as an identity value for good reasons. And in this case, I'm going to start with a 0. Just like I said, I'm going to start with a 0 as an initial value. I'm going to say total comma element, and then I'm going to provide this lambda where I say total plus the element, and I'm going to just walk through this and produce the result of this operation. Now, obviously, in this example, what we did is we took the even numbers, doubled the even numbers, and we reduced it. Well, obviously, what's the result? We want to see the result out of this operation. So we can potentially just output it or store it to a variable if we chose to, and you can see the result is a 60. So how does the reduce operation work? So the reduce operation simply says, I'm going to take the initial value, which is a value of 0, if you will, and then it takes the value 0 as an operation. We'll call it OP. That operation could be a plus, could be a product, could be whatever it could be that you want it to be. And it takes the first element in this collection, which happens to be a 1. So given this value 1, it's going to perform that operation, and the result of that operation is passed on. In this case, of course, it's a 1 that's being passed on to another execution of the same operation. But this time around, it's going to work with the second value, which is the value number 2 in this particular example. And then this kind of goes on and on until it no longer has any more value to process. But if you really look at it, this is a nice feedback loop that we are going through. In other words, the output of a certain stage becomes the input for the second stage, and the output of the second stage becomes an input for the third stage, and there's a nice feedback loop. So if you really think about it, this is an operation you have. It takes a step forward, takes the input given to it, it takes the data, performs the operation is the output, and then that output really becomes an input. You move forward and feed it back into this computation, and you keep rolling back forward. Some languages call this a reduce operation. Some languages call it accumulate operation, and others call it inject. Whatever that the language designers feel like calling, they normally call it. But in general, in functional programming, we should really be comfortable with this operation called the reduce operation. One of the things we should be careful about is reduce doesn't mean a single value. So I have a slightly different definition of what a reduce is, and that is you go from a stream and you apply a reduce and you end up with a non-stream, and that's basically what a reduce to me is. So it means that you go from a stream to a single value, or you go from a stream to a list, or a stream to a set. Anything but a stream, you have reduced it to something else. So it's a reduction operation that you're performing at this particular point. But what is important to keep in mind in this case is reduce happens to be a very common operation. And you should be really comfortable using the word reduce even when the word you see in front of you is not reduce, because the operation is reduce. For example, this looks a little verbose after all. Why can't we simply replace this with a sum? Because that's exactly what we really wanted to do. Well, the sum will be a reduce operation. So if somebody says, what are you doing here? Well, we are reducing it. That's what we are doing. Well, obviously, this code will not work, unfortunately. And the reason is Java gives us an error that the stream interface doesn't have a sum method. Well, the reason for that is, if you really look at what the type of the output here is, it's a stream of integer. Now, if you really think about a stream of integer, this is a stream of t, which is a generic type. Now, if you take a generic type, it doesn't make sense to perform sum on generic types. I mean, if I say sum of people, you're like, what does that even mean? Or sum of books or sum of dogs, it doesn't mean anything. But what you can instead do is you can say map to int over here. Now, it turns out this is no longer a stream. While you got as an input a stream in this case coming in here, this actually is an int stream that you are getting. And obviously, it makes sense to perform some operations on integers, and as a result, that code actually works. So this is a reduce operation, but very specialized reduce on the integer. So sum is a reduce operation. Now, obviously, you may say, why not have a product? They just didn't care to provide one. But you could use a min, you could use a max, and so on. So these are all reduce operations as well. So for example, you can say min over here. And in this case, what is a min? It's an optional of integer 4. And of course, the minimum value happens to be a 4. On the other hand, if I say max over here, that's a 20. But keep in mind, min and max are reduce operations as well. And that is something we should really keep thinking in our mind, or these are reduce operations. So reduce comes in a lot of different flavors in the case of functional programming, and different languages give specialized tools for reduce, as we can see in this particular example. So we saw the functions that are filter, map, and reduce. Now, one of the things you should be extremely careful is that in functional programming, functions are required to be pure. So what does it mean by a pure function? You know, a lot of times when people talk about purity of functions, it's important to understand what purity really means. And I'm going to say pure functions do not have side effects. So this is one of the first things about pure functions. Pure functions don't have side effects. And what does that really mean to us? Well, what it means is they are idempotent. So in effect, what that means is idempotent. So in a sense, if you give the same input, well, what do? They give you the same output, no matter how many times you call them. And that's one of the nice character of a pure function is it gives the same output every time you call it with the same input. Now, why is this so important for functions to be pure? Well, the reason is one of the things that functional programming heavily relies upon is laziness of evaluation. So what is laziness? Laziness is where you could evaluate something now, or you may evaluate it later, or you may skip evaluation entirely. Now, if you have mutation, and if you say you're performing an operation, the question obviously is, did you do this operation before that change, or did you do it after the change? If it's immutable, it doesn't matter when you do the operation. So the reason functional programming emphasizes purity of functions literally is because laziness cannot survive in the presence of mutability. Now, in that regard, what does it mean to be a pure function? I'm going to give two definitions here. The first one is obvious. Unfortunately, most people think that's the definition of purity, but the second one is as important, if not more important. So what is the first definition? A pure function does not change anything. So this is an extremely important rule to follow. If you're writing a pure function, you shouldn't modify anything, period. But as important, if not more important, I would argue a pure function does not depend on anything that may possibly change. And this is extremely important to keep in mind, because if you don't honor this, then the results will be broken. So its purity is not just what you don't change, it also what you don't depend on that may possibly change outside of your context. So if you have a mutable variable, and if your function were to depend on the mutable variable, your function is no longer pure. So you got to be very careful about this as well. Now, the problem with this is functional programming heavily relies on this. Unfortunately, Java is not a functional programming language from day one. This is a concept that's been thrown together at a much later date. If you look at languages like Haskell, language like Haskell was created from the day one as a functional programming language, and you cannot perform mutability in languages like Haskell. On the other hand, in Java, the compiler will only protect you so much. And if you were to mutate things, there's nothing to really safeguard you, and you got to be really careful about it when you write these functions. And I've seen a lot of developers make this mistake, and me included. I've done this mistake myself, which is kind of scary, because I always tell people don't do it, and when I find my own code doing that, it's kind of very scary. All I can claim is temporary insanity, or maybe the aliens attacked and wrote the code for me. I didn't write it. But it's kind of scary when you see the code like that happen. So we should really avoid mutability. A case in point, I've seen this code quite a bit, so let me share that with you right here. So let's say what we want to do is like what we did a few minutes ago. I want to take these numbers and I want to say stream.filter, and then I'm going to take the elements and get, let's say, element mod 2 is equal to 0, and only get the even numbers from this collection. And then I want to say over here, map given an element times 2. And notice how things are going so beautifully well so far. But then the problem is not to total it, not to take the value and sum it, but we want to really get a collection of numbers that are double of the even numbers. Unfortunately, what I've seen people do is to take this value, let's say integer right here, and then you say in this case a double of even, and then you say is equal to new array list. So this becomes an array list of those values in here. And then unfortunately you come in here and say for each, and then you take the result of this, and then you say double of even dot add, and then you add the element to it. And then you come back over here, and then you're trying to output this particular value right in here. Well, let me go ahead and immediately say, don't do this. I want to always put this comment here these days because we live in a world of people tweeting things, and somebody takes a photo of this and of course post it, and they say this guy's an idiot after that. So now take a photo if you want to. So the point really is you don't want to do this. Why is this such a bad idea? Well, the reason this is a bad idea is that you're performing a mutability right there. It's not just any mutability, this is a shared mutability. And as a result, the compiler would not tell you that you are wrong, and you're going to see this result come out of this. Now, this reminds me of an experience I had. I had a developer email me one day and said, hey, I have this code that I've written, and it worked fine until yesterday. And it's always nice to see these kinds of emails, isn't it? And the minute I read those words, I didn't even bother reading the rest of the emails because I know what the problem is. And I immediately scanned down to the code this person has sent me, and what I found was a code with a for each, and where they are taking the manipulated data and they're sticking to a collection. And all I had to say is, don't do this. Well, the email went on to say, this worked fine until yesterday, but this morning, I decided to make this into a parallel stream, and nothing is working after that. Well, that's the problem. This code may pretend to work when you see it. The worst way to look at a code like this is to run the code and say it works. I quit using the word it works these days. I always say the code behaves. That's all I can say. So this is behaving in a certain way. But in this case, of course, if you ever were to parallelize this code, the result becomes unpredictable. Because you may have a race condition and some data may be dropped, it may be overwriting something. So this is the wrong way to really write the code. So what is a better way to write this code actually? Well, a better way to write this code would be to actually use the reduce function. But if you're going to use a reduce function, what you would have to do in this case is to, first of all, do some extra work. You got to start with the initial value, which is called the identity. And in this case, you may say this is a new array list, which is empty. But then you have to write a second argument where you take the value that is being accumulated. In this case, let's say, the list that you are getting and the element. And you would have to say something along the lines of list.add, and then, of course, add the element. But then you would have to, unfortunately, return the list as well, because Java does not have a way to easily, you really wish add was returning the object that you added to, but it doesn't. So you'd have to write a code like this. But in the third part you would have to write over here is a list1 comma list2. And in this case, you would have to write a piece of code where list1.add all, and you add the list2 to it, and then return the list1 to it. And then, of course, write this code and wonder if it's going to work. But do raise your hand if you want to write that code yourself. Not a single person volunteered here. Yeah, so what do you do normally when you have to write code which is so ugly, but you don't want to write it? You find the interns to code that, isn't it? No, just kidding. Well, that's why you use an API that will take the burden out of your hands. This is really error-prone. This is hard to write. And to get it right is really difficult, and then maintaining this becomes really hard. Wouldn't it be so cool if that can be done for you? Well, if you understood what was going on here, what was going on is you started with the initial collection. You started with then a local mutability rather than a shared mutability, where you take the given element, add to a local list, and return that list. This part, the last line, is for parallel execution, divide and conquer. You have sublists now, and you're putting these sublists together. Here's a way to think about it. If I want to total the age of everyone in this room, I can start with him, give him a value 0. I can watch this value go through the room, and slowly it kind of keeps bouncing back. Or I can say, I got a better idea. Let's take all the people in the corner of the room, and every row is going to start computing, and so are the people on the other side. So in one shot, we're going to have parallel execution for every single row, and the people on the right side are all going to have the values of the total for their own rows. Now I can take the two people on the endpoints and run through across this a divide and conquer. Well, that's exactly what this is doing. It takes the two sublists and merges them together to provide this list. But this is so horribly hard to write, even though conceptually it makes really good sense. So what can we do? Well, remember, at the end of the day, it is still reduce, but we're going to use a collect. So what is collect? Collect is nothing but reduce. So anytime you see the word collect, keep in mind you're performing reduce operation because that's what it really is. So you're collecting. But what do you want to collect to? You want to collect to a list after all. And so as a result, you can simply remove this part from here and simply assign that result to that particular result. And where does this to list come from? Well, now we can get to the talk eventually, which is the collectors that we want to really talk about. So collectors is a utility class which contains the toList function as a static method. So in this case, what we are going to do is to perform the toList operation and be known that what does toList really do? It is doing exactly what you see here, except we don't have to endure that pain. They decided to take that operation and nicely encapsulate it and wrap it so we don't have to really deal with that complexity and we get the benefit of doing it. So as a result, if you want to make this parallel, go for it. That's not a problem at all because the toList knows how to merge these sub-collections into one pretty nicely in a thread-safe manner, so it gives you thread safety. So the answer to this question is, how do you really transform these collections? You want to use the collectors method to perform this particular operation, and that's what collect is really doing. So anytime you see the word toList, know that what it's really doing is something really significant, as you can see here, because that's what it's really doing is merging these things together in a thread-safe manner and giving you the result at the appropriate point, and that's what you're getting really at the end of the day. So that's exactly what toList is giving you in this particular operation. Now, clearly, obviously, the code I've highlighted in the bottom is not only complex, it's also really hard to change. If I decide to not use a list and I want to use a set, that's going to take several minutes for me to make the change to the code, and that's expensive, isn't it? But the beauty of this is I don't have to endure that pain anymore. I can simply say set over here and change it to a set. And now, of course, I've got a set instead of a list, and that becomes really easy. As you can see in this output really quickly, if I were to run this code right in here, and if I were to ask for a toList, you can see the order is being preserved at this point. So look at the output of the code we have. It is 4, 8, 12, and 16. On the other hand, if I say a set, well, sets do not guarantee order of execution. So you can see 16 appear first instead of 4, and that shows that it's a set implementation we are using at this particular point. So what we saw is not only the right way to do it, it is thread safe, it is something you can parallelize very easily when you have to, so that's a better way to do. Of course, having said that, in more recent version of Java, since Java 8, I'm going to say like in Java 9 and 10, there is a benefit you can apply to a newer API to really honor immutability. Let me explain what that means in this context. So let's say for a minute I take this as a list, and in this case I'm going to simply say result is equal to and assign the result to a list. And then I'm going to output the result of that operation in here so we can take a look at what the result appears to be. And it's, of course, 4, 8, 12, and 16, and 20. But unfortunately, though, what if I take the result and do an add, and let's put a 91 into it? Now, clearly, nothing is going to stop you from adding 91 to it, which is probably not what your intention was. And one of the things we care about is truly immutability, where we can apply that. So instead of creating a to list, you can actually use what is called a to unmodifiable list. So you can replace that with a to unmodifiable list. And in this case, it's very much like your to list function. But the difference is the list that you're getting cannot be modified. So line number 14 now is going to cause a runtime failure with the unsupported exception, operation exception, because you no longer can actually mutate it, and this becomes an error at runtime. And so my recommendation moving forward is not to use toList or toSet or toMap, but instead to use a to unmodifiable list, to unmodifiable set, or to unmodifiable map, and that we can get an immutable collection on your hand as well. And those are methods from the collectors as well. So as we are looking at this, we are just beginning to unfold and unpack some of the complex things you can do with the collectors. So let's move on a little bit further. Let's take one more example here just to feel some of the methods we have available to us and the things we can actually do. So let's start with a little example here of a function called createPeople. So createPeople is a function that literally returns a collection of people. As you can see in this example, we have Sarah, we have Bob, Paula. Some people have the same name, some people have the same age, and so on. So that's a nice mixture of these different values that you see up here. Now, what I want to do with this collection is this. I want to say, take the people collection given to you, collection, and then let's say print, comma separated, let's say separated, and the names of each person in uppercase. Now, we all can agree this is not rocket science. Now, simple problems should have a simple solution, and complicated problems should have an affordable solution. Then we are able to get our work done and go home. So this is, I would say, is a simple problem, so I demand a simple solution. Now, you say, I want to do this, and you know how some programmers will tell you, oh, come on, that's really easy. Well, how do you then easily do this? You can say for string name, well, first of all, name is going to come from somewhere, so person, and we will say in this case, a person, we'll start with the person, coming from the createPeople collection. Okay, great, what do I do with this stuff? I can say output person.getName dot to uppercase. Hey, that was not really bad, was it? So when you run the code, you got all the names in uppercase. And then your specification says it's got to be comma separated. And you say, okay, no problem, we'll put a comma towards it. And then you realize that's not what the specification really meant. What they really meant was it should all be in a single line. And so you make that all in a single line. And then when you run it, what do you notice? You notice that stupid comma in the end. Has anyone seen this problem before? Yeah, everyone, isn't it? But the important question is, how did you feel that night? You're like, this is not happening to me, isn't it? And you look at this code and you're like, how do I remove the stupid comma? And then you come up with a very creative idea. Let me put this into a string and I will strip it out. Then you realize the string is immutable. Now you say, let me use a string builder. And your colleague is like, is a string builder or a string buffer? And now you're having a 20-minute argument whether to use string builder or string buffer. In the meantime, the boss is like, are you done yet? And so how do you really finish this operation, right? So this is an example of where the imperative code becomes unnecessarily complex for a really simple problem. So what can we do instead of suffering through that consequence? Now, obviously, in this case, you know how programmers never take no for an answer, right? And somebody says, oh, come on, there's an easy way to solve this problem, they say. And you're like, how is it easy? Well, all you have to do is not put a comma if it's a last element. Gosh, why did I not know that? But how do you know it's the last element? Oh, very simple. Int I equal to 0. And where does that take you, right? And 30 minutes later, we're still solving this problem. And the point is, simple things have to be simple, but this doesn't seem to be that way. Let's give it a try one more time. Let's bring in the collectors in here again. And when you go to the collectors, I brought in the static import on the collectors right there. Now that we brought that in, let's do an output right now and say createPeople dot over here, and we are going to ask it in this case to do a filter. And we will say, given a person, I want to simply say persons get name, Actually, I want to perform a map operation on the person. So we got the names of the person given to us. Perform a map operation again and say string to uppercase, and we'll get the uppercase of all the person's name. And then we will simply use the collect one more time. So in this case, I'll say collect. I don't know what that was. I don't know. But this is a collect. And this collect is going to be what? It's a reduce operation, isn't it? So we just brought in the collect. And in this case, what are we going to do? I want to do a joining operation. So where is this joining coming from? This joining is coming from the collectors API, and that's a utility class that contains the joining function that says, sit back and relax. I will take care of doing the dirty work for you, so you don't have to waste your time and effort doing it, and it becomes really easy for you to work with. Obviously, you want the stream to be used at this point, and so on the stream, you perform the two map operations, and then you perform that particular computation. And as you can see here, it nicely joins the collection of data with a comma or whatever delimiter you want to specify, but there's no comma in the very end, so life becomes really easy for us to use, and that's exactly what joining is doing. Now, when you use functions like joining, you're able to get the work done really quickly rather than having to waste your time and productivity and fight with it. You can get the work done very nicely and move on, so that becomes really useful. So that is basically what joining is providing for us. Now, having said this, there are times when we want to not only join the values, but we may want to take the values and partition it. Well, this is a very common operation we perform in our work. You may be given a collection of data, but you may want to partition the data into multiple different grouping, if you will. For example, we might say, let's partition the people in this room with people who are wearing glasses and those who are not wearing glasses, for example, or people who are wearing hat and people who are not wearing a hat. So we could start grouping people into different categories, and how do we really do that? Well, it's such a common operation, and one of the things you want to really get out of a good, meaningful API is that higher level of abstraction. If the abstraction is too low level, we get really dragged into the details, and we're not able to really do things productively. So one of the reasons I love functional programming is the nature of functional programming. So let's step back for a second. In the world of imperative style, what does it really mean to be imperative? Imperative style is where you tell what to do and also how to do it. And this is one of the burdens of imperative style, is you not only tell what to do, but you got to spend the time and effort telling how to do it. Now, I want to join the values, but how do you do it? Well, get the first value, and then get the data out of it. Then put a comma, but don't put a comma if it's the last one. That is telling how to do it. Now, one of the very strong way of programming is called the declarative style of programming, in which you say tell what to do and not how to do it. So in the declarative style of programming, you don't waste your time and effort telling how to do it. Instead, you focus on telling what to do. It's like working with a smart colleague. You can say, let us send this to the client, and they take care of the rest of the things for you. You don't have to tell them what sending to the client actually means, and they have to take the stamp and lick it and stuff like that. You don't have to, be very specific. They figure out the details. You just need to tell them what you want. Now, the reason I'm going this route is the nature of declarative style is very powerful, and we should really keep that in mind. And part of the reason I'm a big fan of this functional style of programming is that functional style, actually, it turns out, is declarative style of programming plus the use of what are called the higher order functions. And this is the reason why functional style is so powerful. Functional style is declarative, and it intermixes the higher order functions with it. And as a result, the power of functional style of programming actually comes partly from the declarative nature of this kind of style of programming. So we can leverage this declarative nature very nicely and raise the level of abstraction so we don't have to get bogged down in the details. So how does this really work? Going back to this code, if you will, I want to, let's say, partition the group of people who are, let's say, younger than 30 and older than 30, just to pick a random number. Well, in that case, what you can do is you can go back to this code right here, and you can get the stream, if you will, and I'm going to simply output the value from this collection. But as we go through here, I say stream, and then I will say dot collect. Again, keeping in mind that collect is nothing but a reduce operation. And then within the collect, I'm going to say partitioning. So in this case, partitioning. So let's say partitioning by. I love this function because finally a function which is longer than my name. So that's basically a partitioning by. And what do I want to partition based on? Well, given a person, I want to take the age of the person and I want to partition based on the age of the person. Is it partitioned by? Let's try this again. So partition by, I can never keep these names in my head. So, all right, can somebody help me? What's the name of the function? Or is this partition? Partitioning. Oops, now too many words. So partitioning, let's try this again. There we go, try it. Nope, still not right. All right, who's going to Google that for me? So that is partitioning, values, and you want to partition that based on, I think it's a partitioning by. Is it by? All right, thank you. So I love pair programming, as you can see here. No, that's not still working. So no suitable method for. So collect and, you know what, it helps. I do have collectors brought in here. So anyway, you get the point. So you can partition this, and the goal here is to be able to partition this into two categories based on the age of the person. And of course, you know what, I'm stupid here, isn't it? Given a person, of course, person.getAge, and you want to say this is going to be less than 30. That's what I wanted to really partition based on, isn't it? So partitioning based on, there you go. So partitioning based on the age value. Well, notice the first one is a false and the second one is a true. So everybody who is younger than 30 in one category and everybody who is 30 and older in the other category. You need to pass a predicate to it and in this case because you want to partition based on that criteria. So that's basically what you did, is that you said given a person, put them into two different categories. Here's a way to think about it. Imagine that you are taking these objects from this collection, and as you're taking these objects from the collection, depending on the criteria that you're using, you're putting them in group 1 or group 2, and the group 1 obviously is true, and the group 2 is false. So the question is, what's the kind of data that we are really seeing at this particular point? Here's a very easy way to find that out. I'm going to simply say result is equal to, and I'm going to set that into a result, and I want to simply output the result over here so we can take a look at the result of it. But if I were to call the function foo on it, it tells us it's a map Boolean, as you can see in the bottom, list person. So you can see the key is a Boolean key, and the values are a list of the objects that you are trying to partition. Obviously, the Boolean can only be two values, true and false in this case, one that met the criteria and the other one that did not. In this case, people less than 30 versus people who are not less than 30, and that's what you're getting at this particular point. So that gives us an idea about how we can perform partitioning. Now, obviously, as you can see, there's a higher level of abstraction. So you're being declarative. You say what you want rather than how to actually do it, and that minimizes a lot of your effort, as you can see in this case, and that makes your life really easy. And that's basically the declarative and the functional style mixed together to get that particular result or response in this case. Now, that's great so far. Yes, please. Oh, yes, please. A little louder, please. Yeah, so the question is, can you partition the list into three groups? Not quite using the partitioning function, but it's a nice segue into what we're going to see next, which is grouping by. So partitioning literally is only into two groups, but if you really want to take it into multiple groups, you can use the grouping by operation at that point. So the answer is yes, but with slightly a different function than partitioning itself, and that's where the grouping function is going to come in handy. So let's see how we can do that. Now, before we talk about how to use grouping, let's talk about a problem we want to solve and then see how that can be solved in a more effective way. This can be a nice competition you can have at work. If somebody is a non-believer in declarative style of programming, you can throw this challenge at them. So here's the list of all the people in here. What I want to do is I want to group these people based on the names of the people. So I want all the Sarahs in one group, I want all the Pauls in another group, I want all the Jacks in another group, and so on. And so I want to perform this grouping. Now, this is something that I realized one day, and occasionally you go through life for a long time without realizing some facts. And one day I decided to sit back and think about all my friends, and I noticed a pattern which was kind of shocking. And each of you may have a different result, and this is something you can do on a boring Saturday night. All the friends, think of their names, and how many of your friends have the same name? Well, in my case, I have the most number of Brians as friends. I don't know why. Almost every friend I have seems to be, every alternate friend is Brian. I mean, these days somebody says, can I be your friend? I say, is your name Brian? They say, yes, sorry, it's taken, right? It's overloaded. So you can see how many people are in the same category, and you can find it. So in this case, what I want to do is to separate them into these groups. What I want you to think about is buckets. I know with people and buckets is not a good metaphor, but think of buckets. So I have buckets where the buckets are labeled based on whatever you want the label to be. In this example, my buckets are going to be labeled based on the names of the people. So I have a Sarah bucket, I have a Bob bucket, I have a Paula bucket, and so on. Now when I start taking the people out of this collection, I'm going to put them into one bucket based on what their name is. And that's exactly what you're doing, distributing them across the buckets. Oh, don't forget, you want to distribute them across buckets not only sequentially, but you may want to do them in parallel as well. So if you want to do this in multi-threading, you want the result to be correct. You don't want anyone to fall between the buckets and get lost after all. So as a result, you want to not only do this sequentially, you want to do this correctly in parallel as well. How do we do that? Well, without even talking about parallel, you can give this exercise to somebody to work on, and guess what they will do? Let's go through a mental exercise for a minute. You create an empty map first of all. You take one person, you get their name from the collection. Well, do I have that name in my map? No, you don't. Let me create a new list, an empty list. Add this person to the empty list. Put them into the map with that key. Take the next person. If that doesn't exist, repeat the previous step. If it exists, go get that list first of all. Add this element. Who wants to do that? Write that code. Raise your hand if you do. Right? No. That's boring, isn't it? And it's error prone, it's boring, it's verbose, and you write that code and it makes you really sad. Why? Because you had to write that much amount of code, isn't it? Now, I really wish I had elders who warned me when I was young, and I really wish I had known about this. When I was a young programmer, I used to keep my children on my lap and program. I always tell young parents these days, please never do this, because I'm the last programmer in my entire family. My children looked at me and said, Dad, this ends with you. So I am the last programmer. And I remember one day I had my son in my lap and I was coding. You know how children are. When you're coding, they hit the keyboard like this, which is great because they gave some variable names which are really nice. And one day, my son kind of, as they grow and sitting in your lap, one day he said, Dad, this is what you do for a living? And then he got off and left and said, I'm never doing this again. So we lost a programmer, So these days, I never show the code to anybody, right? So just entice them saying this is cool until you trap them in. So the point really is, that code I talked about is just absolutely verbose, really error prone, don't want to do it. So what can we do instead? Well, here's an idea. Let's actually start with a map, if you will. And the map is going to be what? A string, because the names in this case are strings. And then I'm going to say a list of person I'm going to bring in, and I'm going to say by name is equal to, and what we want to do is to display the by name. I'll call it a result out of being lazy for a minute, and that's a result I want to print out. But what am I going to say here? Well, create people.stream, and then we will use a collect operation. And what am I going to do in the collect? I'm going to say grouping by, and this is going to be given a person. I want to take the person and get the name of the person. Now you clearly recognize that's a function. So in other words, the grouping by takes as a parameter the function object or the function lambda, functional interface. So when you run this code, what are you expecting this to do? Well, notice Bob only has Bob, but Sarah has both the Sarahs. Jill has Jill alone, but Jack, of course, has two Jacks. You don't see it over here. So that's an example of how you can see these kinds of grouping. So essentially with that's such a potent function, you were able to perform the grouping operation of this data very easily. Now, clearly in this example, I take the collection of people, and by name, I got all the people who have that name in this collection, in this bucket. So the first bucket is Sarah bucket, which has the 2 Sarahs. The second bucket is Bob bucket, which has all the Bobs, in this case only one, I guess, and so on. But you say, wait, that's not what I really want. I want the person's name, but all I want here is the age values or their email address or whatever that may be. So if I want a list of integer, how do I really get it? Pardon me, before we do that, let's go back to this code really quickly one more time and do a little bit of a change here. So given a person, I want to get the name of the person right there. So that's a little simplification for using a method reference than using a lambda. Now that we did this, I want to go to the person and say, I want their age values. I want all the Sarah's ages. I want all the Bob's ages. I don't care about anything other than that. So in other words, what I really want to do is to not put the person in the bucket, but right as I take the person near the bucket, extract the age and put the age in the bucket and not the person itself. So this comes down to comma mapping operation. And then you can say, given a person, get the age of the person, or right there, and then put it to a list at this point, and you can perform a list operation. So this becomes the operation of performing the grouping. While you're grouping, you perform the mapping operation as well. So in this case, you said Bob is the key, but the value is 20, but Sarah is the key, but the value is 20 and 22, and so on. Now, I want to take a pause here and admire at something which is absolutely amazing and powerful. And that is the collect method is taking a utility function in collectors. But here's a unique character of collectors. Collectors are extremely capable of a recursive function. You probably noticed the recursive nature already. A few minutes ago, for the grouping, I only gave that function. Now we said you're going to group on that, comma, and now you give yet another collector. Mapping is a collector too. So this is absolutely phenomenal, where you can take a collector and build a collector using another collector, which can be built with another collector, which can be built with another collector, and you can keep going until you can't be sane anymore. So the point is, it's a nice recursive structure. It can lead to really nice power, as you can see, where you can keep building this nicely in this hierarchy. So that's basically what we did. We performed a grouping, but in the middle of the grouping, we performed the mapping as well, and then we took the data out on the other side. So that gives an idea about how we can perform this nice operation of mapping in the middle of grouping. But not only can you do that, there are times when I don't want to map the person, I don't want to map their age. Like, for example, one question I may want to ask is, how many Brians do I have as friends? Or how many Sarahs do I have as my friend? So I want a count of those values. Again, keep in mind the declarative nature, the higher order of abstraction that you want to really be able to use. So for that purpose, I'm going to go back to this code and say long. And in this case, I want a collection of these as a key, but these are going to be counts. So I'm going to say counts over here, and I want to print the counts at the very end of this. And what am I going to do? I'm going to take this all here, and in this case, I'm going to say counting and ask it to perform the counting operation on the collect itself. Let's make sure I got this correct. So this is going to be the value that I'm bringing in, and I'm going to perform this grouping operation. Let's start with that. And then taking this grouping operation, I want to say counting, and I'm going to perform the count operation into it to get the result of it. Oh, it says incompatible value type. You know what? Let's just take this away for a second. We'll come back to that in a minute. Just simply say var for a second. I don't care about the detail at the moment. Let's see where that's taking us. So notice at this point it tells us that we got a Bob. Of course, remember I was trying to count, isn't it? My brain did not flow through that properly. It's not a list of integer, just an integer, right? For every key, you want to know how many elements are there. So what is the result of this? A map of string comma long, That's what you are getting at this point, or the counts that you are getting out of that. There you go. So at this point, what you notice is the value Bob, there's only one of them, the value Sarah, there are two of them, and so on, and you're able to perform the counting operation along the flow as well very nicely. So as you can see, this is extremely powerful, isn't it? And not only that, you can do this in parallel as well. It's very thread safe. And I can't overemphasize that. To keep in mind that not only are these working really well sequentially, they work really well in parallel as well. And that is one of the biggest benefits of relying on abstraction and delegating it to another responsible, I use the word responsible because they know what they're doing. I usually don't. And the reason is I have to write my application code in the middle of taking care of 1,000 other things, but they have a focus on making it thread correct, thread safe, and as a result, I can rely upon that more easily. So, but of course, you look at this and say, all right, that's great so far, but what I want to do here is to take this long, but I want to make it an integer after all. Why? Well, I was working on an application where I have a function that I have already, and that function was taking an integer as a parameter. Well, this counting gave me long, and now I'm like, okay, I got this collection of long, but I got to cast the long to an integer and pass it to that function. And that really left a bad taste, isn't it? It's like, I don't want to be performing the casting when I'm calling it. Why can't I just have a collection of data of integer right off the bat? Well, it turns out you can. And this is again where this beautiful hierarchy really comes in. And to emphasize that, there are times when you may not just want to perform one transformation and be done with it. You may want to perform a transformation, and while you're doing it, you may want to perform another transformation. Now, granted, I would say this takes a lot of effort to write this code. If you ask me, oh, Venkat, do you naturally sit and write this code? I will be very honest about it. No. There's a lot of banging on the keyboard, kicking and screaming and crying involved in it because it's not that obvious to write it. But once you write it, the code becomes really fluent and also less error prone than the verbose solutions. And as we get better at it over time, I get better at writing it. So even though I take time to write these code these days, I end up taking a lot less time than I once used to because I've been practicing this more and more in getting this code really writing. So what are we going to do here? I want an integer absolutely. If I say counting here, notice that does not work. Why? It says inference variable d has incompatible equality constraint integer comma long. So in English, what it says is you are getting a long, whereas you want to stick that into an integer, I can't do it. So what are you going to do about it? Well, this is where you can build on it. You can say collecting and then, and this becomes a really powerful operation. You're saying I'm collecting all right, but I'm not done, and then I want to perform yet another transformation. So you can say collecting and then, and to this collecting and then you can say counting, and the middle of counting, what do I want to do? I want to perform a transformation of this data. So I take the long and convert to an int value at that point. So this gives a way for you to perform a series of transformations at this as well. So in this case, you're saying I'm grouping based on the name, and while collecting, I want to also take the counting value and transform it. Now, this may look a little intimidating when you look at it, but the same hierarchical structure we talked about earlier comes in. This is a lot like what you saw earlier with mapping, if you will, and you said person get age, comma, to list. Notice that similar structure emerging here as well. It's just that we are using that in a different context, if you will, than we originally did. So that abstraction of rolling upon these series of transformation is extremely powerful. This is a nice way to be able to express the code. Now, like I said, it takes a lot of effort to write it in the beginning. Over time, we get better at writing it. And even if it is taking more effort to write it, it's very well worth it in my opinion because it is not only less code, it's not only more concise code, and I cannot emphasize this more, it is also a very thread-safe code as well. So for the effort you put in now, you get a much better return on your investment, and so it's very well worth it. So when people look at this and say, oh my gosh, it's really complex or hard, we need to really keep in mind the mileage we get out of that code, which is a lot more than the code we will be writing, so it's well worth the effort to do it. So we looked at a number of these methods available as part of the collectors, and I do have to say that the collectors is one of the most intriguing APIs, in my opinion, in the JDK. It's been there since Java 8. They've been adding few things to it every release of Java. But if you really don't know what to do on a Friday night, just open up the Java doc and spend your time with collectors. It would be really quality time, and you would be happy you spend the night with collectors. Hope that was useful. Thank you.